Hello everyone and welcome to my lecture on resonance part 3. In this lecture we will discuss about some questions on resonance. But before starting doing the questions, solving those questions, let's go through the points that we should remember while drawing the resonance structure, finding out the stability of the resonance structures. So these are certain points which have to remember while detecting, by drawing the resonance structure and finding out the stability of the resonance structure. The first point is, more the number of covalent bonds, more is the stability of the resonance structure, because we all know that the formation of bond is an exothermic process and it brings stability to the structure. The next one is, the more the delocalization, more is the stability of the structure. The canonical structures with no charge or neutral compound is more stable. The canonical structure where the negative charge is on electronegative atom is more stable than structure in which positive charge is present on electronegative atom. The last one is the canonical structure in which the opposite charges nearest and similar charges furthest are most stable. So these are the points which we should remember while drawing the resonance structures and finding out the most stable or least stable resonating structure. In the last video we have discussed that all resonating structures do not contribute equally to the hybrid structure. It is the more the stability of the canonical structure, the more it contributes towards the hybrid structure. So let's detect let's find out that through certain questions that how to find out that which is the most stable resonating structure and which is the least stable resonating structures. Let's see the first question, which is the most unstable resonating structure of bicarbonate ion. So first you should know how to draw a bicarbonate ion. So this is how a bicarbonate ion is. So let's do the possible canonical structure of bicarbonate ion. Here in the bicarbonate ion, one of the oxygen is having a negative charge, and so it can donate its electron and go into resonance with the carbonyl group. The moment the negative charge is donated here, the oxygen, the carbon here becomes pentavalent, and so the double bonds immediately breaks and we reach to the next structure, canonical structure 2. Similarly, the lone pair electron on this oxygen, can enter into resonance with the carbonyl group, and we can reach, similarly this double bond immediately breaks and we reach to the canonical structure 3. This particular carbon atom can donate its electron now to the electropositive oxygen atom, and we can reach to the canonical structure 4. Now, what is it? All these 4 structures, will it contribute equally to the hybrid structure? No, all will not contribute equally. So which is the most unstable resonating structure of bicarbonate ion? You see, in all structure 1, 2, 3 and 4, the number of covalent bonds are same. It is only in structure 4 the number of covalent bond is least. So structure 4 will be the least stable structure. So we have already reached to our answer, which is the most unstable resonating structure of bicarbonate ion. 4 is the most unstable resonating structure of bicarbonate ion. Now what about 1, 2 and 3? Will they contribute equally? No, they will not contribute equally. You see in structure 3, the oxygen, the electronegative oxygen atom is having a positive charge, and so after 4, 3 will be the next unstable structure. And if you look at structure 1 and 2, they are almost of the similar energy, and so how will be the stability order? The stability order will be the structure 4, the most unstable, then the next unstable structure is structure 3, and structure 1 and 2 are of equal energies. Let's go to the next question. How many resonance structure does the following compound have? What is the compound? Yes, the compound is anilinium ion. So you all must be aware of the structure of aniline, in which we have a benzene ring and to which a NH2 group is attached. But this is anilinium ion, where one more hydrogen atom is attached to the nitrogen. And now let's see what should we do. The question is, how many resonance structure does the anilinium ion have? So the moment you get the question, you start drawing the resonance structure, because the double bond is adjacent to a positive charge. Double bond of the phenyl ring is adjacent to the positive charge. So you immediately start drawing the resonance structures. These are the 5 resonance structures, and so you write that the number of resonance structures are 5 for anilinium ion, and you get the answer wrong. The number of resonance structures in anilinium ion is only 2. Why? Because whenever nitrogen is there in the compound, you should be very careful. Nitrogen can only form, maximum it can form 4 bonds. But in anilinium ion, if the nitrogen enters into the resonance with the benzene ring, then nitrogen will be forming 5 bonds, and it can never form 5 bonds. So these structures are not possible at all. Nitrogen will not at all enter into resonance with the double bonds of the benzene ring. It is only the double bonds of the benzene ring that will be in since they are in conjugation, they will be in resonance, and we can have only 2 resonance structures. Let's look at the next question. Which is the most stable resonance structure for para-amino benzaldehyde? Para-amino benzaldehyde. Para-amino benzaldehyde can have this 5 resonance structures. Now out of these resonance structures, which will be the most stable resonance structure, and that we need to find out. So you can see that in among all this structure, the first thing we need to consider that which one is having a maximum covalent bonds. So you see in structure 4, the number of covalent bonds are maximum. So structure 4 will be the maximum, the most stable structure. Above, there is another thing which you should note, that in all this structure, the oxygen is having negative charge in all the structures. It is the positive charge on the carbon which is delocalized. So in structure 4, another notable thing is the positive charge is delocalized to a maximum extent in structure 4. So the structure 4 is the most stable structure compared to the other structures. Coming to the next question, Which is the most unstable resonance structure of benzaldehyde? Benzaldehyde is having this 4 canonical structures, and which is the most unstable? You yourself can solve this problem. Pause the video, solve the problem, and then again come back to the answer. Among these structures 1, 2, 3 and 4 all are forming equal number of covalent bonds, and so we can't stress on that point. But among all these structures, it is only in one structure the oxygen is having positive charge. So that is structure 2. So structure 2 is the most unstable resonance structure. The most unstable resonance structure of benzaldehyde is 2 because the most electronegative atom in the compound, that is oxygen, is having positive charge. Let's look at question number 5. Which is the least stable resonance structure of this compound? This is vinyl ammoniumine, a double bond having a NH3 group, NH3 plus group attached to it, so vinyl ammoniumine. So among this 1 and 2, this is very easy. Again here there is nitrogen, so let's see the number of covalent bond nitrogen is making. In structure 1, nitrogen is making, already nitrogen had made 4 covalent bonds, and so it is not possible for nitrogen to make further bond. So see this structure. In this resonance structure, nitrogen has made 5 bonds, which is not at all possible. So this structure does not exist at all, and so this is the least stable structure. So structure 2 is the least stable structure. Without shifting any bonds, you can say that structure 2 is the least stable structure, because in structure 2 nitrogen is making 5 bonds, which is not possible, and it is the least stable resonance structure. Question number 6. Write the order of stability of the resonance structures of formaldehyde. This is formaldehyde molecules, and these are the resonance structures. Now out of these 4 resonance structures, you can easily see that structure 3 and 4 are having a less number of double bonds compared to structure 1 and 2. So they are less stable structure. But out of structure 3 and 4, which is, are they having equal energy, or one is having less energy, another one is having more energy? So see, compare structure 3 and structure 4. In structure 3 and structure 4, in one of the structure, that is structure 4, oxygen is having positive charge. Oxygen does not like to have a positive charge because it is an electronegative atom. So obviously structure 4 is less stable compared to structure 3. Now look at structure 1 and 2. Out of structure 1 and 2, they are having equal number of covalent bonds. So which is more stable, or which is least stable, or are they having equal energy? Structure 1 and structure 2. Look at structure 1 and structure 2. Compare structure 1 and structure 2. In structure 1, the structure 1 is an uncharged species, and in structure 2 there is charge separation. So closing your eyes, you can say that structure 1 is more stable compared to structure 2. So what is the stability order of these four resonance structures? So the stability order is 1, greater than 2, greater than 3, and greater than 4. So order of stability of the resonance structure is 1, greater than 2, greater than 3, greater than 4. Coming to the next question, question number 7. Write the order of stability of the resonance structure of diazonium ion. These are the 4 resonance structures of diazonium ion. So what is the order of stability of the resonance structures of diazonium ion? Are they all same or they are different? Let's see. So first find out the number of covalent bonds present in these structures. So structure 2 and structure 4 are these two structures are forming lesser number of covalent bond compared to structure 1 and 3. So which will be the less stable structure? Structure 2 and structure 4 will be less stable compared to structure 1 and 3. So now let's focus on structure 2 and 4. Out of structure 2 and 4, are they going to have equal energy or different energy? You see, in structure 4, the nitrogen, which is the most electronegative atom in the molecule, is having a positive charge. So, but that is not so in the case of structure 2. So structure 4 will be the least stable, then the less stable structure is 2. Out of structure 1 and 2, which is the less stable structure? Structure 1, out of this structure 1 and 2, the nitrogen here, the carbon is having, in structure 3, carbon is having a negative charge and nitrogen is having positive charge. Carbon being less electronegative than nitrogen is having negative charge, whereas nitrogen, which is more electronegative, is having the positive charge. So structure 3 will be the least stable structure. So how is the order of the stability? The order of the stability is, if you compare 1 and 3, then 3 is less stable than 1, and 2 and 4, if you compare, because 1 and 3 is having same number of covalent bonds and 2 and 4 having same number of covalent bonds. So the order of stability is 1, greater than 3, greater than 2, greater than 4. Write the order of stability of the resonance structures of vinylamine. This is the structure of vinylamine, and if you now compare 1, 2 and 3, you can easily see that structure 2 is having less number of covalent bonds, and so structure 2 will be the least stable. Structure 1 and structure 3 are having equal number of covalent bonds, but in structure 1 is neutral, structure 3 has charge separation, and so the charge separation, and not only that, the nitrogen is having a positive charge, and so that will make the structure 3 the least stable. So the order of stability is 1, greater than 2, 1 greater than 3, greater than 2, because 2 is the least stable structure because it is having less number of covalent bonds compared to 1 and 3. So among 1 and 3, 3 is less stable compared to that of 1. So, the order of stability is 1 greater than 3 greater than 2. 2 is the least stable structure. Here there is an interesting question. Yes, the molecule is made up of 3 similar atoms. In both the structure, the molecule is made up of 3 similar atoms. So, now you are asked to compare the 2 resonance structures and find out which is least stable. Now, in these 2 structures, you see in structure 1, similar charges, that is, a positive charge is closer to each other. Okay, and in structure 2, the similar charges are far apart and unlike charges are closer to each other, and so structure 2 is more stable compared to structure 1. Coming to the last question, which is the least stable resonance structure, 1 or 2? In 1, this is a very simple one. In 1, there are lesser number of covalent bond compared to that of 2. So, 1 will be the order of stability of the resonance structure is 2 greater than 1, because 1 is having a lesser number of covalent bond and 2 is having more covalent bonds. So, without looking into any other thing, if the number of covalent bonds are more, then the structure will be the most stable. So, structure 2 is having more number of covalent bonds compared to structure 1. So, 2 is more stable compared to 1, even though the positive charge is on oxygen. So, if the number of bonds are more, even there is a positive charge on the electronegative atom, the structure becomes more stable. So, here we come to the end of the lecture. If you like my video, please subscribe, like, share and comment. Thank you for watching my video, and before I end my lecture, I want to share a thought. If the mountain was smooth, you couldn't climb it. Thank you and bye.